Okay, welcome to this lesson then on similar shapes again, lesson 3 on this topic. This one's on volumes of similar shapes. Okay, so a quick recap. Two shapes are similar if one is an exact enlargement of the other. See, we've done this one before. Okay, this shape here, okay, is definitely, so this, if I call this one A and this one B, sorry, shape B is definitely 10 times bigger, you see, than shape A. 7 times 10 is 70. 5 times 10 is 50. They're similar shapes. And in the previous video, which you should have watched before this video, we found out that the area scale factor of enlargement of similar shapes, you take the length scale factor and square it. Okay, so this has got length scale factor 10. The area scale factor would be 10 squared, which should be 100 times bigger. If you don't believe me, you can work out the areas of both these shapes, and you'll see this is 35 centimeter squares, and this is 3,500 cm squares. And these two are definitely 100 times connected, if you like. All right, so example 1, just one example today actually, because we're in the groove now with this sort of thing. So pause the video, write this question down, and then come back to me when you're ready to have a go at the solution. All right. Okay, welcome back. So shapes A and B are similar, no probs. State the length scale factor of the similarity. Okay, well, I'm just looking at obviously for one pair of matching sides. These two match here. So I think that 6 times 3 is 18. If you can't do it in your head, all right, then you just divide the two if you want. So the length scale factor is 18 divided by 6, which is a factor of 3. Okay. Find x and y. Well, I'll find x first of all, can't I? Because I know that x is going to be 3 times 3. Okay, because it's 3 times bigger. So x is 3 times 3, which is 9 centimeters. And y, obviously y, something times 3 is 15. Well, working backwards, I would divide by 3, wouldn't I? Okay. So y is 15 divided by 3, which is 5 centimeters. All right. So I'll put those on the picture. Okay. X is 3. Sorry. X is 9. And y is 5. Okay. I'll go on to the next slide for part C. I need a bit more space. Okay. Right. So the volume of C. Remember, a cuboid's volume is length times width times height. So it's 6 centimeters times 3 centimeters times 5 centimeters. So 6 times 3 is 18. 18 times 5 is 90 centimeter cube. And if I do, why did I call it C for? Sorry, guys. I just did a video before this where the shape was called C. Volume of A. All right, sorry, my bad. And B again is length times width times height. This could be quite big actually now. Okay, 18 times 9 times 15. I got you. Okay, 18 centimeters times 9 centimeters times 15 centimeters. We don't mind using a calculator today for this lesson, guys, because the number's going to get quite big. Okay, if you do 18 times 9, and that's 162 times 15, this actually is quite large. Okay, it's 2,430 cm cubes. Okay, done that one. Sorry, right. Done. Work out the volume scale factor. Well, so look at your two volumes. Do them in a yellow highlighter if it works. It does. Here's my two volumes, 90 and 2,430. Okay, so if you take your calculator, I'm trying to see, basically, how many times 90 goes into 2,430. So I think I'll just divide. It'll be quicker, won't it? Okay, and you're going to get the volume scale factor is 27. Now I'm hoping now, okay, we're starting again this like pattern spotting groove. I'm going to write down again underneath the length scale factor. From the first part of the main task, it was times by 3, you see? And the volume scale factor is times 27. So I'm looking at a connection here, okay, and I'm thinking about, remember now the area scale factor was the length scale factor squared. So I'm thinking about powers here. It's just a hunch, all right? Actually, I know really, okay? But I realized that 3 cubed is 27. So I'm thinking today the volume scale factor might be the length scale factor cubed. Okay, I guess I just saw the cubes here, look. I'm thinking about cubes for some reason. All right, so we'll try now in the main task and see if that's correct. So put the head in main task for me. Okay, and then there's actually going to be 2 slides again like the previous video. So best thing to do, okay, is pause it here. All right, have a go at these 2 questions. All right, and then come back to us. Okay, then welcome back. Then we'll go on to the next part of the main task. And if you are on this part of the main task, I will say, all right, that for this one, number 4 is a real challenge, but the volume of a cylinder, the formula is pi r squared h, okay? R is the radius, and h is the height. So pause it here, guys, and then come back to us for the answers of both those slides. Okay, welcome back. Here's the answers. All right. And as we go through these, okay, I'm going to check my theory. All right. So if you mark these first, I've got 2 and 8. Is 2 cubed 8? Yes. Is 3 cubed 27? Yes. Next slide. Is 10 cubed 100? 1000, sorry. Yes. And is 5 cubed 125? Yes. All right. So here we go, guys. So my theory is correct. All right. So checking question. Here it is. All right. It says 2 shapes. Well, maybe pause it first, write it down, okay? Then come back to me when you're ready for the answer before I get too carried away with this beautiful mathematics. All right, welcome back then. So 2 shapes are mathematically similar. It doesn't mention what shapes they are. All right, so maybe I just draw like a random, maybe, I don't know. It mentions volumes. Perhaps I pretend they're cuboids, maybe. Yeah, it doesn't say what kind of shape they are, does it? So, and it won't actually really matter here. Okay, I just like to draw some pictures to help my brain, basically. Okay, A there, and B is obviously way bigger. All right, B is obviously way bigger, so I'll draw B, just a tad bigger. It's only a sketch, remember? Okay. Okay, the volume of A is 7 cm cubed, and the volume of B is 448 cm cubed. The surface area of A is 11 cm squares. What is the surface area of B? Right, so I'm looking at this now, right? And I think I'll write down at the top, look, all right? What we found out today, okay, is that the volume scale factor is the length scale factor cubed. Okay, now I see I've got 2 volumes here. See? This one and this one. I'm going to write both of those down. Okay, 7 cm cubed and 448 cm cubed. And I think I can work out the volume scale factor. Can't I? Okay, so I've got 2 volumes. I'm going to do 448 divided by 7 and see what I get. So 448 divided by 7. That's like is 64. Okay. Obviously, to see what this new surface area is, I can't use the volume scale factor, all right, or even the length scale factor. I need the area scale factor. So what I'm going to do, okay, I'm going to rely on the fact from last lesson now. All right. Well, actually, no. First thing I'll do, actually, okay, is can we see that if the volume scale factor is 64, the length scale factor must be 4, because 4 cubed is 64. If you don't know your cube numbers, remember, okay, you could always do the cube root of 64, and that will give you 4. So the length scale factor is 4. Okay, but that's still not what I really want here, is it? All right, I need the area scale factor to compare these two surface areas. Remember, we showed, didn't we, in a previous video, the area scale factor is the length scale factor squared. So I am going to do 4 squared, which is 16. So the area scale factor is times by 16. So now I know to get B surface area, I just do 11 times 16. All right. So the surface area of B is 11 times 16, and that's going to be 176 centimeter squares. And we're done. Okay, now this question, I actually took it off an old exam paper, but changed the numbers a bit. Okay, and this was right at the end of a higher tier paper, which tells you this question is a bona fide A-star topic. So if you follow this, then that's great. All right. If you didn't, go back and watch the video. All right. Apart from that, thanks for listening. As always, stay safe, and we'll see you soon.